Okay, everyone, I promised some of you a video or set of videos tonight over our extra credit assignments. And so here we go. So this is technically IM3 second semester material. And this is actually set 3. I still need to do another set for the previous extra credit, but I want to get you guys off to a good start with this week's extra credit assignments. So here we go. So before we dive into it, I wanted right here to discuss basically how log functions work. And the key thing to understand about log functions is a log is the inverse of a power function or exponential function. And that a right here, guys, whatever that number a is, that's your base, just like in the base of a power. So we can rewrite this log expression, or I should say equation, as a power or exponential equation simply by taking that base right there, a, to, in this case, whatever that answer c is, and that's going to equal the b. Okay, and that's basically how logs work. So as another example, notice this log has base 2. We're going to read it as 2 to the 3 power equals the 8. And you guys should know 2 cubed is 8, because 2 times 2 times 2 is 8. So it works, right? If you look at the last expression, notice that log has a base 5 on it. So we read it as 5 to the 2 power equals 25. And of course, we know this is true as well because 5 times 5 is 25. Okay? Now, another clever way I may have shown you in class is, follow the black here, guys. I could have simply just did a 2 power. Look right here now. I could have just done a 2 power because it was base 2 on both sides, like so. And the 2 cancels out log 2 because they're inverse functions of each other. And notice I get 8 again equal to 2 to the 3rd. Follow the black marker one more time. Notice I had a base 5 here. I could have done a 5 power, you see, on both sides. The 5 power and the log 5 basically cancel or kill each other off because they're inverses. I'm left with 25 equal to 5 squared. So there's 2 good ways to approach these problems, okay? So let's get to the problems that I gave you here. On number 43, notice the base is 3. I could have simply said 3 to the negative 5 power has to equal this, which is 1 over 243, and we're done. And, excuse me there. And as you can see down here, guys, look on the bottom left, I wanted to make sure you understood if we actually plugged in the values in the calculator, 3 to the negative 5 is 0.004 and some change. And notice 1 over 243 is exactly the same number. So this expression, or I should say equation, is valid, is it not? Okay, let's take a look at another one, 44. Notice there's a 6 there for my base. So couldn't I say 6 to the negative 3 power equals 1 over 216? Again, if you look at what I did on the calculator, isn't 6 to the negative 3 this value, and 1 over 216 is exactly the same value, so our equation right here is proven valid again. But anyways, all we're doing basically, guys, is taking a log equation, rewriting it as an equivalent exponential equation, okay? Let's do a couple more. This one, notice the 12 base right there. So couldn't I say 12 to the 2 power has to equal 144. And of course, we all know that 12 squared is 144, right? 12 times 12 is 144. There's one more we're going to try together right now, number 46. Could we not take that 16 and say 16 to the 1/4 power has to equal 2? Let's see if that agrees with the calculator. Notice 16 to the 1/4 power is equivalent to 2. And so, guys, that concludes this video. Converting log equations, rewriting them into exponential equations. All right, see you in class.